Assalamualaikum and hi everyone. Today we are going to present about area approximation of Vase. The members of this group are Nurain binti Rukman Hakim and Nuliana binti Muhammad. The introduction of this study is: this study applies the trapezoidal rule, a numerical integration method used to approximate the area under a curve. The vase, treated as a solid of revolution, is analyzed by dividing its height into smaller intervals and measuring the radius. These measurements are used to approximate the vase surface area. Next, there are three objectives of the study. Objective number 1 is to determine surface area of vase. Number 2 is to apply numerical methods to the real-world problems. And number 3 is to determine the result of the vase by using manual calculation. For methodology, we have two steps. Step number 1 is we collect the data from the graph. To begin the calculation of the vase surface area, the vase shape was drawn on the graph paper, and then 9 points are chosen to represent the difference of height along the vase. These values were recorded in a table for further calculation. Step number 2 is surface area calculation. For this calculation, we have 4 steps. Step number 1, identify the interval AB. Step number 2 is to identify the step size or number of subintervals like H or N. Step number 3, identify the data. And step number 4 is apply trapezoidal formula.
Next, we move to the implementation. First of all, we have decided to draw the vase on a graph in landscape. The reason is because it was easier for us to divide it for two sides since it is almost symmetrical and the sides are upper and lower sides. After that, we choose 9 points for each side to plot. Then connect one point to one point with straight lines. After getting all the points, we were using Excel to find the interval AB, which is A, the first point of the x-axis, and B was the last point of the x-axis. Next is to find the subinterval, and for the upper side, the value of the subinterval is 8. Furthermore, we also can find for the step size, H, that can get from formula B minus A over N. And the best reason is to find the function for each side. Then we use the same step for the lower side of the vase. Last but not least, by using all the information, we can use the formula of trapezoidal rule as shown here. Find for the upper half area and the lower half area. And finally, we got the area for the vase by subtracting the upper half and lower half area. Move to the conclusion. The trapezoidal rule is an effective method for approximating the surface area of the vase, providing accurate results that align with expected outcomes and demonstrating its capability to handle complex curves. By increasing the number of intervals, the method enhances precision and refines the approximation of the vase shape, making it a reliable tool in numerical analysis.